Imagine a herd of elephants, so enormous they could touch the stars. That's how big thunderclouds, also called cumulonimbus clouds, can get. They tower over the earth, filled with swirling winds and tiny water droplets, much like a crowded playground for air and water. These enormous clouds are like giant factories constantly working to create something spectacular, lightning and thunder. These clouds are so big because they are fueled by warm, moist air rising from the ground. As this warm air rises, it cools and the water vapor inside condenses, forming those impressive thunderclouds. The process is a bit like when you see your breath on a cold day. The warm air from your lungs meets the cold air outside and tiny water droplets condense, becoming visible. Have you ever rubbed a balloon on your hair and watched it stick to your hand? That's static electricity, and it's similar to what happens inside a thundercloud. Inside the cloud, millions of tiny ice crystals and water droplets collide with each other as they're tossed about by the wind. These collisions create static charges, just like the balloon rubbing against your hair. The cloud becomes a giant battery in the sky, with positive charges gathering at the top and negative charges building up at the bottom. The energy keeps building until zap! Lightning is a sudden burst of electricity, a giant spark jumping between the positively and negatively charged areas of the cloud, or between the cloud and the ground. It's like when you touch a metal doorknob after shuffling your feet on the carpet. Zap! A spark jumps between you and the doorknob. Lightning happens incredibly fast, traveling at speeds of up to 220,000 miles per hour. That's why we see the flash of lightning before we hear the clap of thunder. The lightning bolt heats the air around it to an incredibly high temperature, almost 5 times hotter than the surface of the sun. This rapid heating causes the air to expand rapidly. The incredible heat from the lightning bolt causes the air around it to expand so quickly that it creates a powerful shock wave. This shock wave travels through the air as a sound wave, which we hear as thunder. Remember, sound travels much slower than light. This difference in speed is why we see the lightning before we hear the thunder. You can even tell how far away a storm is by counting the seconds between the lightning flash and the thunderclap. Every 5 seconds represents about 1 mile of distance, so if you count 10 seconds, the storm is about 2 miles away.